what happened there? And welcome. I wasn't quite expecting that. I think my voice is broken. Maybe I've hit puberty. Right, in today's episode, after all my excitement where my voice broke, we have all the way from down the road, French engineering superiority, a team Time Scylon. This is quite possibly the most beautiful bicycle frame I've ever seen. The finish on this is just the lick. And I was rubbing my hands in glee thinking this is going to be one of those ones which is like the DBs, the mutts nuts, how else can I say it, but utter brilliance. And then it descended into complete shiteness when the chap said, please could you fit Campagnolo Super Record into it? I mean, who would want to fit Campagnolo Super Record? Who would want to fit Campag anyway? It's the crux of it is loads of people. Now, fitting Campag is a bit of a nightmare, really. But anyway, the frame is here, so now we need to go and put all of those things together and me to uphold French engineering superiority. So this is the Skylon Frame. Now, I mean, really, it is beautiful. It is just absolutely ace. The finish on it is really, really good. And even the bits that you can't see, like inside, which you can't see because it's too dark, is just immaculate. There's not a mark on it. The bearing seats, they are absolutely the mutts nuts. They're perfectly formed, top and bottom. Really, really, really good. Dimensionally, now, let me get one of my gauges. So that's a 45.95. So this frame has a BB386 Evo. Now, colloquially, that is called BB386. Just BB386. Lots of people refer it to as BB386. But this is a 45.95. So if we push that in, that is just about going in. Oh yeah, there you go. I don't want to push it in any further, but that is within spec. Let me get the mics out and then show you that. Before we get the mics out, let me get the torch. So here's the torch, and then we do a light test. Nothing. which means the hole is around. So now let me get the mic out. Oh, here we go. This is the is it the drive side, non-drive side? It doesn't really matter. I've checked both sides. They are bang on. Mic over here, so we've got 45.9 add for 7, so it's 45.97, which is bang between the spec because the spec says 45.95 to 46. So Mr. Kessler, Mr. Vrooman, if you are watching, some people can actually follow standards and then don't try and sue you afterwards. Right, so initially what happened was this is the cable guide that was in that frame. The chap originally wanted cable operated Campag, and then after a bit of umming and ahhing, he ended up going for electronic Campag. So I took the cable guide out. So this is the cable guide. Even the cable guide's well made. The only thing I did notice was it's pinched in a couple of places. I don't suppose that's particularly difficult to sort out. It's just in a cable liner that would need replacing, but that's quite nice that you can take it out. This is Campagnolo Super Record. This is carbon and a titanium axle. The big difference with Campag is the bearing is an interference onto the axle, whereas everybody else has the bearing an interference into the housing. I say everybody else, the exception is Luck's BB65 has one bearing on the axle and the other one in the bike, and they have some variations of it, but you know, that's the crux of it. This has got a hearth joint. Now I think, yeah, the holding down together screw in the middle is left-handed on the titanium variant. So that's what I'm doing. That hearth joint is extremely difficult and costly to make. Okay, so that is the mating component of this. So, okay, I haven't got them in the right position, orientation, but you can see how they go together, like that. As a piece of engineering, that's quite often used on marine cranks or big cranks, just so they can get them in and out, but it's not very stiff. So you've got all this titanium everywhere, and then a joint in the middle, which is quite flexible, so you lose in that respect. The other thing is, and you can see it better on this side, is Campag's bearings are made by a company called Schaeffler, or FAG. On the inside, there is no seal, so they're free to be exposed to dirt, muck, whatever. On the outside, there's a rubber seal, but that rubber seal is not part of the bearing. So this is effectively an open bearing. So Campag uses open bearings, and the seal is external. Okay. The other thing is the preload system. So on Campag, the preload system is by means of a preload washer, and this is where the fatal flaw is, because if the bike frame moves or the bearings wear slightly, then you get insufficient or difficult to comprehend preload, because the preload can vary quite considerably depending on how wide the frame is. So if it's just like a millimetre wider, then that causes a problem. Right, so that's an overview of all of this. So let me take you inside and then show you what we're going to do. Here we go! It's that time of the video again. Start recording. Right, it is time for PowerPoint. And today's episode, we have... Oh, fuck, is this working? I think it's working. Right, fuck. We have Campag. Have we got the pen working? That's a good thing. Is the pen working? Pointer options, pen. Oh yeah. In case anyone's wondering, I've had to temporarily stop usage of the pen because I've hurt my hand a little too much. So yeah, some sign language for you all there. Don't waggle your mouse too much. It might hurt yourself. Campag is shite. Time is better than licking. Oh no, I've spelled it wrong. It's supposed to say Angela Merkel's pussy cat, but I spelt it wrong. Right. By Hambini, age 5. Remember to get the merch. You can support me in my legal conquest against some individuals who have decided to. Well, in fact, let me go into that a little bit more. On May the 17th, 2021, my YouTube strikes run out, and at that point you will find out exactly who's been messing around and what I've done to them. The what I've done to them is worth watching because it's completely unexpected. But anyway, right. Grinder. You can find me at Timmy's Tea Room on Tuesdays. Now, there are a few people out there, namely some visiting professor at, I think it was Bolton Polytechnic, who's not even an engineer actually, he just likes to slag me off. Calls me a plumber. Nothing wrong with plumbers. And that wasn't peak talk. That was not peak talk. The Engineering Wanctionary episode 3. So this is like engineering slang and what it means to mere mortals. T is tight. FT is fucking tight. And FFT is not fast Fourier transform. You can work out what that is supposed to be anyway. Now the next one always used to be a measure of acidity, but now it's a synonym for Pornhub. pH. Reamed is getting told off. Bum twitching is crapping in one's underwear. And fanny features is a bird playing the pink oboe. So usually a bird with a long neck, like a flamingo. Right, the summary of what we need to do. Right, the Time Scylon. Is this fucking pen working? Oh, it is. You know about that. Well, we'll go on to it in a bit. Campagnolo Super Record, and we need to make the two fit together and work. Right, Time, recently bought by Cardinal Cycling Group. I've never heard of them. They were owned by another French company called Rossignol, who makes skis. Cardinal Cycling Group, the only thing I can find out about them is they are from a place called Arkansas. That's supposed to be how you pronounce it, but when I look at it in my, shit, dyslexic, immigrant fuckwit interpretation of it, I think it's pronounced Arkansas. But there you go. Right, anyway, this is it. I don't really know much else about them. So, yeah, do your own Googling. Right, this is the bike frame. Bottom bracket geometry and alignment were both the lick. They were really, really very good. There was no detectable voids. And the misalignment was basically zero. You're not going to get much better than that. It's almost like someone's machined the hole in it. I don't know if it is machined. I think it could be. But it is absolutely perfect. If it's like been molded into that, then hats off to that. But it is the hole is so good, it almost appears to be machined. This is the dump from it. So I mean, we can look at it. It's round. It is very, very round. Now, if some of you who are new to the show may not know what a void is, so what I've done is I've taken some x-rays to show you. These are from an open bike, so a bike made by two individuals called Gerard Vrooman and Andy Kessler. They tried to sue me because I said their bike was dangerous, they didn't like it, and they wanted the videos taken down. Unfortunately, they're still up there, so you can have a look for that. It's this cesspit bike. It's worth watching. This is an x-ray of, I think it's the down tube, and you can see like these crinkles, which I've highlighted with the yellow ellipses. They're effectively where the carbon has moved. You could argue they're a void. Some people call them a void because there's nothing, sometimes nothing in between them. And also this highly engineered £3,000 Euro frame is just full of voids. So the voids are like these things here, where the colour is black. So when you're shooting an x-ray, dense things appear white. So material will make the x-ray go white. So where this aluminium riv nut is, it's all white because it's stopped the x-ray going backwards to the negative. That's that void. Another void there. And oh bollocks. Right, this is the same thing, but the exposure's turned up. So the crinkles show up a little bit better. But I don't know if crinkles is the right word, but it becomes more apparent. And you can also see this one on the top right hand side there. That looks like some major shifting. You can see the colour difference. That is a void. You want to avoid that, because it's structurally not strong. So if you have your Toray T800 or T1200 or whatever the going number is these days, and you have a displacement in the laminate, then you will find that the strength is nowhere near what's quoted. Really, these days, the weakness is the resin. It's not the carbon fibre cord or cloth, as it were. The carbon fibre is there for strength and the resin is there as the filler. When you bake them all together, it becomes semi-unibody. It's not quite perfect because you have to lay the layers on at different angles, but that's one for a different day. In comparison, I just showed you the very round circle from the Time bike. I mean, look at the Orbea one. So the blue line highlights the edge of the bottom bracket. So you can see how thin it is there, and then how wide it is over there. It's not even close to being round. It's crap. And then over here we have the Boardman bike, and I did a basic light test on it, and I mean, here you can see it's locally defective, so it's not round. So you've got like high spots or low spots, however you want to call it, but it's not round. Right, some quirks of the Campag system. So this is a picture of the Campag Super Record dismantled. I've even left the plastic on it, so that's not there in running. It's just there because that's what was sent to me. So you've got a hearth joint, which is extremely difficult to machine, and it's very costly to machine. On this particular side, there's a snap ring which holds the bearing in, which I think is almost overkill for that, really, unless it's an axial stop. And again, I don't know, I'm just guessing, it might be an axial position. The bearing is open, so the bearings are FAG Chronitech, which is ceramic balls, and then the steel is extremely hard, so martensitic hardened steel. And that's about the best ceramic bearing you can get, but even then it's not perfect because it's quite poor when you come to vibration. So if you're going along a rough road, the vibration tends to put micro pits into the bearing. Now if you go on forums, they'll say, oh, my Campag bearings lasted for years. If I had one of these, and lots of people see how I trash the bike, they wouldn't last, I don't know, 5,000 Ks, something like that. They'd get absolutely hammered. So the drop in rolling resistance you get from the ceramic bearing is probably not worth it. And then finally, you've got an outer seal, which, given that you've got these ceramic bearings which are marketed for very low rolling resistance, this outer seal is, it's just adding loads of drag to it. So that's that. Here's a picture of what an open bearing looks like. So that is an open bearing. The thing in here is the cage. So each of these are rivets, and this thing is the ball, but you can't see it because it's behind part of the cage. So the cage is like a ribbon that goes around. All of the bearings have it. Actually, not all of them. Some of them have a snap ring. So a lot of enduro bearings are plastic. If you want stiffness and to go fast, ideally you want metal. That's not always possible in every size, but metal is better. Some of the bearings, like SKF, have TN9, which is a polyamide cage. They're quite good, but I guess I'm a purist. You really want metal. So NTN, pretty much all of them are metal. FAG is pretty much all metal. NSK is moving towards plastic in some areas, but that's life, isn't it? They're not all worried about minuscule differences, rolling drag or stiffness. Right, this is a schematic of a Campag Ultra Torque. So there's the hearth joint, and it's got a bolt through the centre. Now be aware, hearth joints are not stiff. So you've got your Campag cranks, which are carbon and allegedly the stiffest thing in the world, and then you've got a joint between the two halves which is like flexible like a piece of rubber. There's an interference fit on the shaft to the bearing, which I've just shown you in the previous slide. There's also an interference fit on the other side, and then you have something called a transition fit, which is where the bearings push into the bottom bracket, which is unusual for bottom brackets of this day and age. Almost all Shimano bottom brackets have the interference fit in the housing. So the housing fit would be there, but Campag has it here. The end result is, for the user, certainly for the user, an interference fit into the housing is much easier to deal with. And the final quirk, there's a transition fit there as well. The final quirk is this. So this thing here is a wave washer. So the wave washer is required to generate preload. So you need the bearings to not skid. So if you've got a turbo trainer with a wheel on, one of the things you have to do is wind the knob in to get enough tension onto the tyre, or otherwise it slips. Now, as you wind more tension in, it becomes actually more difficult to turn the turbo, but you can put more watts through it before the tyre slips. That's all that preload, well, it's an analogy for preload. The preload in Campag is adjusted by that gap. So that gap between there and there. So if I draw a line there and there. So the smaller you make that gap, the more the preload. More compression, basically. Right. This is what I was trying to illustrate on the previous slide, but in graphical form. So extension is it's probably more like compression, but if you reduce the if you increase the compression, you're basically moving up the scale that way. So you'll hit a limit where you've got too much preload. If you haven't got enough compression, you end up over here. So you've got less force. So the force is proportional to the extension. So depending on the frame, you could be here or here because of frame geometry. Now in the case of, let's pick a Shimano crank, the point that where you are is fixed because it is a displacement system. It's not reliant on any kind of compression, which is in my opinion is an Achilles heel. People I supply, I generally try to avoid using Campag. Right, the fix. Now the chap in question, he was a bit uncertain whether he wanted EPS or cable. The advantage with EPS is the routing of the electronic wires is a bit more easy than the cable, and also he could take away the cable guide. So he ummed and ahed about it. Right. The next thing is, now on this frame, and they're not all like this, you know, I don't think Time are immune to having, you know, shit frames. Everyone's going to have them. But in this case, the frame is basically perfect. Now I thought it looked, if you took the frame and then just gave it to some machinist, asked them to clock it, they'd probably say that was a machined hole. It's that good. So you don't really have to consider some of the things that you used to consider on other frames, like alignment. You're only worried about retention to hold it in. And then we need to consider the Campag preload system, which I just said on the previous slide. And it's now time to show the 3D. Right, let me... So this is a 3D mock-up of the bottom bracket that was made. So you cannot really see much in there because it just looks like the box inside a BB386 shell. This is the innards of it. Now what we've got is two halves, so the part, I can't actually see, fuck. That bit is pressed in, and then this bit, oh, is it that one? Fuck. That one is threaded into the male part, so the male part effectively goes into the frame and that threads in. Now there's some subtle things on here which you'll see in the shortly, but the tooling to get this to go, there is a small lip. Now that lip is important because otherwise when you apply load you're much more likely to strip it, especially on a thread together. So there's a small web effectively to stop you stripping it, and then it just literally will thread in. Now over here you can see a gap between the bearing and this part of the bottom bracket, so that there and there. So the bearing is here. Okay, so the two blue surfaces, that gap is there for a shim and a wave washer, but I just haven't shown it on this 3D. The other bits are clearances. So into the that's the drive side. The drive side has an interference fit, which is a 46mm interference fit. On the non-drive side, it is size for size. So I mean, the hole is basically perfect. So I made the collar pretty much the same size, maybe half a thou, which is 10 microns roughly. It's actually 12, but there you go. Clear, so it will go in basically. It's a very, you know, a transition fit is one way you can just tap it and then go in. Now the key difference between this thread, well I call them thread together bottom brackets, and other ones is where I put the threads. Now on most bottom brackets that are of this type, they put the threads in the middle. On this one, I've put the threads all the way over to one side, and it makes the thing stiffer. In the case of this Time bike, probably isn't required, but every little bit counts. So it has, where the thread engagement is basically reinforced. So you've got like 10mm of metal reinforcing it, whereas on other frames and other bottom brackets of this type, it's thin. It's like 2mm, something like that. And they do it pure and in the middle purely because it gives you better cost ratio. So the amount of aluminium or metal or titanium, or in Praxis's works, some of theirs are steel, you can use less metal. So that is how that works. I don't think there's anything else to show you. It's a tooling. Bearings are 6 out of 5. That's about it really. Right, as I've mentioned, thread together is only as good as the frame they go into. If you've got a shite frame and you try and push it in, you're fucked. Stiffness in this case is derived from the frame. So you've got perfect alignment in this case, but in other bikes, if you have misalignment, then you will lose a bit of stiffness because you'll make the thread engagement asymmetrical, so it'll be more loaded on one side than the other. But the advantage is, I mean, it's fairly idiot proof. Now I say fairly idiot proof because some of the things that come through this door are probably the extreme. Now this is a wheels manufacturing thread in the middle bottom bracket. So you can see the threads are basically thread in this region here. Okay, that's where the male and the female parts thread together. So in the case of the bottom bracket you've just seen, which is my bottom bracket, they will be all the way up here in that kind of region. The other thing is, because your alignment is based on the frame, if you've got a choice, you're much better off with a one piece, because it may not be quite so obvious, but this bottom bracket is bent. The number of threads on that side is much less than the number of threads, sorry, the total length on that side is less than the length on that side, so it's bent. The bottom bracket was misaligned. It was a Cervelo bike. They use BB right, soda factor, and you can also see, you know, the chewing up here to remove it. It was a bit of a crap one, that one. So the chap sent it in. He had problems with creaking. I think his bike shop fitted this. It was okay for a little while, and then it just came on after, I think it was 800, maybe 900 kilometers, and then he spent, I don't know, $100 trying to fix it, and it was pretty much futile. So there you go. Right, if you've got any questions or comments specifically about the technical bits, please bang in the comment box below, and obviously hit like and subscribe. That's it. Right, let me take you back to the workshop. So this is the finished article. It's a bit grubby because I've been fiddling around with it. So it threads up like that, and then the crank goes through. Now what we can do is we can just give this a slight test. So we can test this before it gets on the bike, and what we need to do is measure a gap of 86.5 millimeters. So it's only for a little test. Probably all the threads. There we go, that's about 86.5. Right, with that in situ, that width is correct. Now we can put all of this together. Now with Campag, the problem is the preload system. So what we've got is we've got the wave washer here and the corresponding recess in the other side. So I'm going to pop the wave washer in there, and then I've got a choice of 3 to pick from. Probably pick this one just to start off with. We'll see how we get on. Pop that in. Okay, so it went past the little burr there, and then we can assemble the crank. Doesn't actually matter which way we put this, but that is the non-drive side, so we'll put it in correctly. Pop that it's not engaged yet. There we go. So the teeth are now engaged. Okay, they're not in a line, but for this purpose, it doesn't really matter. We'll put the lock nut in. Turn it anti-clockwise because it's a left-handed thread. So it's starting to bite now. Okay. So what's happened is we've got too much preload on it. So we need to take that off and then adjust it. Just messed around with the shims and you can see it's spinning. Now you're probably thinking, well, it's not spinning that well compared to one of my bottom brackets. Well, that is a limitation of Campag's bearings. So it probably is difficult to see, but in there is quite a lot of drag generated by the Campag seals. Now I haven't put this on perfectly square. I think I'm one tooth out, but again, this is just for test purposes. But we know that it works in principle. I will say this though, for a ridiculously expensive crankset, the bearings that come with this, they're going to need a couple of 100 Ks to get them well bedded in. I thought they would be better than that straight out of the box, but you know, you can't get it all, can you? So now we will try that on bike. So what we're going to do now is we're just going to clean this up. And then put a dab of grease onto the drive side. Don't normally use grease, I usually go for retaining compound, but this frame isn't going to work the same way as the others. So we then need to put this in. So let's just assemble this. So I've got a 6805 adapter, the cup, well, semi-cup to go in, slot that over, and then a return space on the outside, and I cut a bit off the end just to make it a bit easier. Okay, and now we'll thread the handle on and then push this in. Okay. Okay, so that is now in. We'll take that off. This is a view from the other side, so we've missed the cable and it's bang in the middle. Now we'll thread this on. So double dab of grease onto the female threads. And then we can screw that on. Now this is the tool that I made to put it all together. It is a very good fit into the teeth, if I can get them lined up, which I can't. There we go. It's a very, very good fit. The other thing to note is there's a small lip on the outside, on the inside, so it's flat against flat. I'll show you that in a minute once we put this together, but let's just thread this up. Right, we'll get the spanner out and then we'll continue to thread up. So now we can just put the tool on and then thread it all up. That's now tight. The way I've designed this bottom bracket, you can see the actual teeth engagement. There's a small lip, it's only a couple of millimeters between the frame and where the thing actually sits. The reason for that is invariably you're going to get some slippage. So this will not damage the bike frame. You see this has gone in really quite well. I'll show you a bit more on that in a minute. Right, let's try the preload out. So let's pop a dab of grease onto the inside. Pop the wave washer in, and then these. So depending on how thick they are, that adjusts the preload. So I've gone for that one this time around. Might be too much, we don't know. We'll see. Right, let's pop that in. Let's pop the crank in. I think that might be too much. Don't know, we'll see. We might need to actually fine tune this a little bit. Yeah, I think that's too much. Let's just try the other one. We're going for the slightly thinner one this time around. Again, a little dab of grease. The whole way this works is it needs to slide when you put it in, so setting Campag up is problematic. Right, let's try that again. Oh, I think that one's got it this time. Okay, let's try that. Right, the hair teeth are engaged. And it's in line now, for once. Crikey, the amount of drag on those, on the Campag axle's crazy. Right, we might just have to tweak this preload a little bit more. Crikey, right. I've just done a bit more fiddling around with the preload. I did say before this was problematic, but that's how it spins now. There is a bit of play in it, and that play is from the preload system. So we want to make sure the spring is not, the wave washer is not bottomed out. So just about see a little bit, and that is the problem with any kind of wave washer system. You can, if you bottom it out, then you end up with way too much preload, and if you don't have enough, then you end up with no preload. So there we're sort of halfway in between, but we can adjust it if required depending what the chap wants, but in principle it works. So that's what we want. I'm quite happy with that. Ceramic bearings, they're not the most fabulous spin in the world, but and again, don't read too much into that. Campag seals are quite draggy. Now, one of the problems is one of tooling. Now the tooling is, in this case, this. So it's a 32mm socket and the drive on the end of it. So it's all 1/2 inch, it's fairly industrial tooling. This is a Kolnago T45 bottom bracket. So this was made for a chap who needed one. Now this is the same tool that goes on it, and if I locate it up, that's the drive side, so it's clockwise. Take it out, and what you can see is the tooth engagement goes all the way through. So if I get an Allen key just to show you, they are through all. Okay, so it's touching the frame, so the frame has to be bang on. This is T47, so this is my incarnation T47, and on this one, might not be obvious, but there's a flat edge there, so when you put the Allen key through, it stops there. Now the advantage with that is when you put the tool on, it won't go and damage the bike frame. So that is one key thing. And the other thing is it is much less likely to strip because that web that's in the background gives it some strength. So this one goes into here, drive side. So this is a T47, like that. Corresponding side on the other side. Again, this one's when we put the tool on, it isn't going to hit the frame. So there's a very, very small gap. You can probably just about see broad daylight in between there and there, so that's good. That's why that is beneficial. On some of these bottom brackets, you just do not have the space. So whoever designed T47, the wide one, which is what Trek uses, that isn't really all that good. Ah, balls. Right, and that brings us to the end of this video. I really hope you enjoyed it. If you did, remember to whack the like button and put your comments in below. I do read them all. If you've got any questions, then obviously use the discussion box below. And until next time, keep doing things with your hairdressers. I'm sure I've missed something. Well, yes, I have. Really, this frame is excellent. I can't really fault the frame. It's fabulous. The choice of crankset, I'm not a fan of Campag, and that's mainly because of this fanning around with the preload system. You can't just have loads of these things to set your preload. People are just putting them in and not doing that, and they're just expecting to get away with it. And it's pretty, I don't know, I wouldn't say it's scandalous, but it isn't great. Now, this is obviously going back to the chap, so he will be happy, but that really is just about it.